In this video, I'm going to talk about stoichiometry, and I'm going to talk about it in terms of greenhouse gases. And just so everybody's aware what a greenhouse gas is simply a gas that allows sunlight in and traps some of the heat here on Earth. As shown in this photo, sunlight comes in, some of the heat goes back out to space, but some of the gases actually reflects the heat back onto Earth. And the amount of gases really determine what the temperature of Earth is. So without gases, it's calculated that on average we'd be roughly 60 degrees Fahrenheit colder, and more gases is an increase in temperature. And here I have two graphs where from 1860 to now you can see the amount of carbon dioxide in the atmosphere has grown substantially. And if you look at the average temperature, you can see that we have risen almost a whole degree centigrade from around 1950. Now, one of these greenhouse gases is carbon dioxide, and there's a question of where do we know where this carbon dioxide is coming from? Well, chemistry can help us with that. So let's look at this reaction where we have C8H12, and if you remember from the organic chemistry video, if it's 8 carbons, then it's oct. And although it's not drawn out here, if you did, you would see there was all single bonds. So this is octane plus oxygen gives us carbon dioxide and H2O. So when you're burning octane, you're making CO2 and H2O. So you can see in front of these chemicals we have numbers, and these numbers are coefficients. And they're saying in this reaction how many moles react. So we're saying 2 moles of octane react with 25 moles of O2 to give us 16 moles of carbon dioxide and 18 moles of water. And balancing these numbers and these numbers in general are called stoichiometry. So, as we said, that 2 moles of octane will react with 25 moles of oxygen and make 16 moles of carbon dioxide and 18 moles of H2O. But you can also say this is for molecules as well. So it's moles or molecules. Generally, in Gen Chem, we're going to be always talking in moles. We're always going to say moles are interacting with. Now let's see if we can use this stoichiometry to do a question. So here's a question for you. So I personally drive a 2010 Camry, and let's say my gas tank is full of pure octane. How many grams of CO2 would I release into the atmosphere per tank of gas? And assume my tank is 70 liters. The density of octane is 0.703 grams per milliliters. Molecular weight of octane is 114.23 grams per moles. Molecular weight of CO2 is 44.01 grams per moles. Now this is a difficult problem, but try and take a shot at it and come back to the video once you have an answer. Alright, let's take a look at this. So I have the relevant information up here, and this is really just dimensional analysis. As I've said before, dimensional analysis comes up a lot, and this is one big dimensional analysis problem. So going to set up our train tracks. I start with a 70 liter gas tank, and that should be 70.0. Now for every 1 liter we have 1,000 milliliters. That's just a unit conversion. Now we said from the density 1 milliliter of octane is equal to 0.703 grams of octane. That's what your density is telling you, 0.703 grams per 1 mil. Now, the molar mass of octane, you can calculate it, and the molar mass of octane is 114.23 grams, and it's also given here, per 1 mole of octane. Alright? But we don't want to be in octane, we want to be in carbon dioxide. Now, this reaction stoichiometry actually gives us a way to go from octane to carbon dioxide. So for every 2 moles of octane we make 16 moles of carbon dioxide. And if you remember, the original question was how many grams of carbon dioxide do I release? Well, that's just molar mass. For the molar mass of carbon dioxide given here, 1 mole of CO2 is equal to 44.01 grams of CO2. Okay, So let's take a look at our units. Mole of CO2, mole of CO2, cancel. Mole of octane, cancel. Gram of octane, cancel. Milliliters, cancel. Liters, cancel. Our units are grams of carbon dioxide. That is what our answer needs to be in, so we can do our math now. We multiply everything at the top, and we divide by everything in the bottom, and we get that one tank of gas releases 1.52 times 10 to the 5 grams carbon dioxide. Again, sig figs and units need to be in all your answers. And there is a question out there: are humans, do we make the CO2, or is it from natural sources? And depending who you talk to, you'll get different answers. But if you talk to the scientists, it's pretty given that it's all man-made, or the majority of it's man-made. So let's take a look at this. This gray line is how much CO2 is given off by volcanoes. This green line is how much humans give off, and you can see humans give out way more CO2 than volcanoes do on a year-to-year basis. And that's all we have for stoichiometry in this video. See you in the next video.